Hey guys, I wanted to take just a minute to talk about function notation again, but kind of simplify it down because I really think we're overthinking it and we're trying to make it something that it's not. So here's what I've got. I've got three functions that I just kind of found. We've got an F function or formula. Function's just kind of your formula, a G formula or function, and an H formula or function. When they ask you to evaluate something and they're asking you to find f of a specific number, you would read this as f of x equals negative 4x plus 2, okay? So what this is asking you to do is to take the f formula. So I'm going to take that f of x equals negative 4x plus 2, okay? And it's telling me to say, okay, you know what? Evaluate it by replacing the x with a 3. Notice how the 3 is where the x used to be. So if I was to write f of 3, I just had to change that x to a 3. Well, if that x changed to a 3, this one is also going to change to a 3. This is just giving you an input value, okay? A plug-in value. The key here is f of x equals y. The one inside parentheses is indicating an input value. The one outside parentheses or outside the entire formula as the result is your output value. So if they give you something in the parentheses, they're merely asking you to plug it in for the x value, right? That's where the x was. That's what you're going to input into the formula. Then you just work this out. You can use a calculator if you're not real strong, but negative 4 times 3 is negative 12, and negative 12 plus 2 makes negative 10. So you would say f of 3 equals negative 10. And again, this notation has a lot of information. It tells you that we used formula f, we plugged in a 3, and we got out as a result a negative 10. Okay, if they ask me to find f of negative 6, I'm going to use the f function equals, again, negative 4x plus 2. But now I've replaced this x with a negative 6 right there. So if I'm changing the x to a negative 6, this x is also going to change to a negative 6. And so if I do some quick math, that gives me a positive 24 plus 2, which is 26. So f of negative 6 equals 26. Okay, I've used the f formula, I plugged in a negative 6, and I got an output of 26. In the next example, I switched just a little bit and said, okay, now let's find g of negative 4. Well, the g formula, I always write out the formula. Okay, that negative 4 is inside the parentheses, so I can see it is taking the place of x. It's an input value, so I'm going to input it for the other x. And anytime you input, put parentheses around it. It will help you out with the calculator stuff a lot. So if I have negative 4 minus 6, that's going to be like on a number line, negative 4, and then back 6 more means I would end up at negative 10. So g of negative 4 equals negative 10. Again, if I take the g formula and I plug in a negative 4, it will make a negative 10. H of 2 means I'm going to take my h formula up here. H of x equals x squared plus 5x minus 1. Notice how the 2 is where the x is, or where the x used to be. So that's becoming a 2. That means every x value is becoming a 2. And then if I just do some quick work, I get 4 plus 10 minus 1. So 14 minus 1 would be 13. Whoops. 13. Okay? Again, function name, input equals the output. The only real trick or thing where it gets a little bit different is when they say, okay, now find x when f of x equals 18. Again, I'm talking about the f function, so I'm going to write the f function. I'm just pulling this from the top of my paper. Negative 4x plus 2, it's the same f function I had at the top. Notice that the 18 is not in the x position. They're asking me to find x. So I'm not going to be replacing this x. That right there is the big question mark. I don't know what it is. What they're telling me is the whole formula with an x in it has to equal 18. So if you want, you can think of it as, okay, this whole entire thing now has to turn into an 18. You can also think of it as, okay, well, up here it says the number at the end is an output value. That's a y value. So I can think of, okay, this entire equation needs to equal 18 as an output. It's the same thing. It doesn't matter if you write equals 18 at the back or equals 18 at the front. That's not a negative, by the way. That's part of the f. So at this point, I'm going to go ahead and use the one at the back just because there's not that confusing thing back there. So I'm going to solve this just like I have solved equations for a couple of years now. To isolate x, I'm going to subtract 2. I get negative 4x equals 16. Divide by negative 4. And I get x equals negative 4. Okay? If I want to write my answer in function notation, I know it's going to set up as f of something equals something. Well, instead of the x, I now know that x is negative 4. So I can put a negative 4 where the x goes, and it equals 18. So equals 18. When I write it this way, it tells me when I use the f function, I need an input value of negative 4 to make it equal 18. If I was to actually plug in a negative 4 right there, negative 4 times negative 4 is 16, positive 16, and positive 16 plus 2 is 18, okay? If it says g of x equals 1, I'm going to take my g of x formula, which is x minus 6, and I'm going to set it equal to 1. I can it's like I'm replacing this with a giant number 1, not the x, but the entire thing. So you can kind of just ignore that and say, okay, I need it to equal, give me an output, an answer of 1. If I solve this equation, it's pretty quick. One step, just add 6 to both sides, right, to isolate that x, and I get x equals 7. If I'm going to write it back in the function notation, I'm going to say, okay, g of, well, the x value is a 7 equals the 1. So if I plug in a 7 to the g formula, it makes an output of 1. 7 minus 6 gives me a 1 as the answer, okay? If g of x equals 7, just so that we can kind of see the connection here, well, my g of x formula is x minus 6. And now it's not saying plug the 7 in for the x, right? The 7 is not in the x spot. That's not what's happening here. It's saying the whole formula has to equal 7. So I'm going to take this formula and make it equal 7. That's a simple one-step equation. Again, to isolate x, I'm adding 6. So x equals 13. Okay? If I plug it back into my function notation, g of something equals something, the input value, the x value, right? G of x equals y. That's what we saw up at the top. G of 13 equals 7. If I plug in a 13, I end up with 7. And then the last one, f of x equals negative 4x plus 2. This is not saying that the 6 is taking the place of the x, okay? Do you see the difference here between up here, it was f of negative 6. If I'm constantly thinking about that format, f of x equals y, this version up here at the top was telling me what the x was. The negative 6 is where the x was inside the parentheses. This one, if I think about that f of x equals y value, the negative 6 is where the y is, okay? It's my output value. So I want my formula to equal -6 as the answer. All right, solve this equation really quick. If I'm going to isolate x, I'm going to subtract 2. I get -4x equals -8. Then I divide by -4. And I get x equals +2. If I go back to my formula, f of something equals an output, the input value would be a 2 for my x. The output value would be a -6 for my y. All this is a different format to give you an input value or to give you an output value. It's just you're taking a formula and either plugging inside of that formula part, or you're giving me what that formula has to make. Okay, that's really all this is. I hope this helps because there was lots of confusion.